Hello, in this lecture we are going to look at how an airport designer puts lighting, marking and signage at an airport, because operations at the airport are not limited during daytime or during very good visibility conditions. Aircraft may be operating, especially at busy airports, even at night time or times when the visibility is very poor due to fog, bad weather, because due to haze, etc. So during these bad weather and low visibility conditions, the lighting and the marking and signage become very useful. Even when we operate in good condition, the marking and signage helps navigate the aircraft after landing or before takeoff on the airport. So the pilots use these signs. The content of this particular presentation has been prepared primarily by the teaching assistant Yash Kapshikar. Let us start by understanding the functions of lighting, marking and signage. As I mentioned, these are required for good and reliable ground to air visual information to be communicated during landing. Also, we want to have excellent visual information during takeoff and landing to operate safely. During taxiing, we need to get visual guidance so that the pilot does not go to the wrong taxiway or by mistake enter an active runway, which can cause disasters or accidents. And also, as I mentioned, safety during operations in poor visibility or in the nighttime conditions. Now, there is a difference between lighting and marking and signage. Let us first get that clear. Lighting, as you can see, is the use of lights to guide the aircraft. One can have an approach lighting system or a lighting system to help in approach, or during the surface movement one could use lights to guide and channelize the aircraft. Marking and signage, on the other hand, are symbols and letters and numbers used with a particular color scheme and font to mark, to provide guidance to the pilot. Either it could be on the runway and taxiway pavements, or it could be also for guidance between runway and taxiway or taxiway and runway, as we shall see. Now, let us start with the airport lighting systems. So there are many kinds, and I want to first show you the list of all the various types. What you see on the screen right now are the runway threshold lights. Okay, as you can see, these are two groups of green lights which are marking the threshold or the point where the aircraft is expected to touch down. Then we have an approach lighting system, sometimes with these flashing lights, which guides the pilot in the air to approach to the runway and to aim at the correct point. We can also have lights that identify the edge of the runway, or as you can see in the red color, the end of the runway. Okay. So they are called as REILs, the lights that identify the runway end, and then you have RELs, which are the runway edge lighting. This ensures the pilot does not leave the runway laterally and also knows where the runway is going to end. So plan the braking and the reduction of the speed of the aircraft after landing, keeping in mind the color of the lights. Then we have runway centerline lights. These are lights which are on the runway center line, and also you can see in green color there are some lights which are indicating the path that the aircraft is expected to take while leaving the runway. Then we have touchdown zone lights. Touchdown zone is the zone where we expect the aircraft to actually hit the ground. So that area has to be specially illuminated using a particular sequence of lights which are called as the touchdown zone lights. We also have lights at the edge of the taxiway and the center line of the taxiways to help pilot move on the ground, and we also have lights to allow proper visual approach of the aircraft during landing. This is one such system. There are two main systems which we will talk about in more detail. So, under the airport lighting systems, we are going to look at all these lights one by one. Let us start with runway threshold lights. As the name suggests, these lights indicate the location of the runway threshold to the pilots. Why are they needed? What is the importance? The identification of the runway threshold is a very important factor in safe landing, because it allows the pilot to take a decision on whether we should continue to land or we should execute a missed approach, in which the pilot will abandon the landing, maybe go for a circuit and come back and land. So, threshold is the point where the runway starts or the useful runway starts, and therefore, it is very important for the pilot to know the location of the threshold. So, therefore, the region near threshold is given very special lighting consideration. Okay. So, in the direction of landing, these lights are green in color, both sides of the runway there are rows of green lights, but at the end of the runway or the opposite direction, the lights are red to indicate the end of the runway. Here is an example of threshold lighting. As I mentioned earlier, you will see these, in this case there are 5 lights on the left and 5 on the right, they are in green color. Sometimes the threshold has a continuous row of green lights. Now, the threshold, as I said, is the point where the runway or the useful runway starts, but sometimes the threshold is also displaced, right. So, when the threshold is displaced, then the end of the runway is marked with red colored lights, and also there are red lights along the runway, but the place where the aircraft can start its landing is the displaced threshold, and that is shown by green color. Okay. Now, let us look at some approach lighting systems. These are the most important systems according to me, because they are guiding the pilot to approach in the right direction. Now, there is a history behind the approach lighting system, which is going to be abbreviated as ALS from now on. So, after World War II, there was a need felt to provide visual guidance to aircraft when they come in to land. So, a lot of experiments were done both by the US Navy and United Airlines. These experiments were done at a specific airfield called as the Arcata Eureka Airport, which is in California, and after a lot of trials, what they finalized is a 3,500 feet visual approach, for which 38 towers were erected, each of 75 feet high, and on top of these towers, each of these towers we had a 5,000 watt natural gas light. So, this natural gas lighting, this is all early 40s, okay. So, at that time we did not have so much of electricity available, but subsequently when electricity became available, then we started to replace these natural gas lights with what are called as the strobeacon lights. These are actually beacons which are in strobing fashion, therefore they are called as strobeacon lights. Now, the world's first commercial airport to have an ALS system was the John F. Kennedy Airport in New York way back in 1956. Now, there are many categories and many types of ALS approved. This is called as the ICAO Category 1 ALS, which, as you can see, is a series of lights which are initially single, then there are center lights which are 2 of them, and then in the end they go into horizontal bar lights which are 3. So, this was the world's first ALS, developed way back in 1949, and also the first one to be certified by the International Civil Aviation Organization. It also is called as the Calvert ALS. So, ICAO Cat 1 ALS is also called as a Calvert ALS. Now, this particular system was modified. So, we have a modified Calvert ALS, also called as the ICAO 2. Here we use higher intensity lighting, and also you can see there is now a row of red lights 300 meters from the runway threshold lights, okay. And these are used when there is very poor visibility. also called as the ICAO category 2 system, and here is an image of a system. You can see the row of these lights and also the white lights at the end. Now, there are, as I mentioned, many configurations. You have the ALSF 1 and 2 which I showed you. So, these are essentially high intensity ALS with sequenced flashing lights, okay. That is why it is called as ALSF. You also have MALS, MALSF, MALSLR. These are medium intensity ALS systems, either with sequence flashing lights, that is the MALSF, or with runway alignment indicator lights, also called as MASLR. Then you have SSASLR, SSALSL, SR, short simplified ALS with runway alignment, and there are many more types. There is also something called as the omnidirectional system. Let us look at these systems one by one. So, the three most common configurations are the ALSF 1, that is CAT 1, containing just a row of white lights and one band of white lights. ALSF category 2, as you can see now, introduces these red colored bars on both sides of the runway, okay. Then we also have the MALSR, which is medium intensity, and this has got flashing sequence lights, and then there is a pattern on the ground. This is the ALSF 1, high intensity ALS with sequence flashing lights type 1. That is one of the photographs of the system at night. So, the lights on the bottom shown by the arrow, they are all flashing. So, when the pilot sees them, they will also be flashing in this particular direction. So, that will indicate the pilot the direction in which to approach the runway. So, then you have ALSF 2, which is slightly better version of ALSF 1. As I mentioned, that is a band of red lights at the edges. Okay, this is high intensity ALS with sequence flashing lights, and this also has flashing lights, and this is type 2. Here is an example of an actual runway image showing these flashing lights. So, as you can see, the lights are flashing in a sequence, helping the pilot to identify which direction to go, and you can see the green colored runway threshold lights and those two red bars, which are an extension of ALSF 2 compared to ALSF 1. Here is the MALS, or the medium intensity ALS system. So, here you just have white colored lights, okay, which are steady burning lights. Here you do not have any flashing, but you also have something called as MALSR or SSALR, medium intensity ALS with runway alignment indicator lights, or short simplified ALS with runway alignment indicator lights. Both of these are used interchangeably, they are very common, they are very similar. Here is an example of how it is: flashing lights up to a distance of 1400 feet from the end of the runway, and the first 1000 feet are flashing. So, you can see an image of a photograph of this system, and here is an animation of how the pilot sees the system when the pilot comes in to approach this particular type of lighting system. As you can see, here you have only white colored lights which are of medium intensity. Then we have MALSF, medium intensity ALS with sequence flashing lights. So, here you can see an image of an actual airport. Again, you can see lots of stray lights are there, but the approach lights are very clear. There will be flashing lights in the beginning, and then there will be steady white colored lights. Now, we look at runway edge lights. As the name suggests, they are indicating to the pilot the end of the runway. Okay. Why do we need RELs? These are installed at airports generally which do not have any ALS system, because we would like to identify visually the approach end of the runway and distinguish it with the other end shown in the red colored lights. This is intended for use in identifying the runway in some specific scenarios. For example, if you are in the city which is surrounded, if the runway is surrounded by bright city lights, it will be difficult for you to identify, or there may be a contrast which is not missing, there may be no contrast with the surrounding terrain, so it will be difficult to acquire the runway, and also when the visibility is reduced. These are the conditions in which RELs are normally used. They are also classified into three types based on the intensity. You have high intensity, medium intensity and low intensity runway lights. These are typically installed at visual airports, visual runways and rural airports. These are smaller airports where we do not have instrument landing system, we do not have instrumented approach. MIRLs are typically installed on visual runways where you do not allow IFR operations, at larger airports and on non-precision instrumented runways. These are the places where you can see MIRLs normally. And HIRLs, high intensity, are one on only precision instrumented runways. So, various types of runways have already been described, all these names: visual runway, precision non-instrumented, precision instrumented, all that has been explained in the lecture on runways. If you are not aware, please go and have a look at that lecture. Now, let us look at the RELs for operation during visual conditions or the VFR conditions. This is an example of a visual only runway where you have the outline of the runway during night time, and our visibility conditions are having these white lights, and the green lights that you see are the runway threshold lights. This is for the visual, there is no approach system here as you can see. But when you have an instrument runway, then you will have more detailed lights, and also you will be getting intimation regarding how much runway is remaining. So, for example, you will find the lights to be yellow for the 2000 feet or half the runway remaining, it will be yellow in color, and then they will be changed. Now, the spacing between two lights in REL are generally maximum is 200 feet. So, within 200 feet you should get another light. This is also used by pilots sometime to get an idea about how much runway is remaining. They can probably count the number of lights remaining and get an idea. Into 200 would be the remaining runway in feet. Now, at the other end of the runway, you have the runway end identifier lights, because we need to provide positive and rapid identification of the approach end of the runway or the end of the runway. So, for this we have synchronized white flashing lights which are located at the runway threshold. Okay, this is the synchronized flashing lights, as you can see. Then we have lights at the runway center line, which tell to the pilot about the center line of the runway. Now, why do we need them? What is the requirement? After landing an aircraft, you need to have proper directional control, so that by mistake you do not stray outside the runway, especially when that happens when you are landing in a crabwise condition to take care of crosswinds. Sometimes also during takeoff you do not want to veer off the runway by mistake and go into the soft area. So, during night time or low visibility times, it is important to keep yourself almost at the runway center line. These lights are used in precision instrumented runways where they are essential. Now, the runway, they have wide center lights installed at every 50 feet distance, and interestingly these white lights, they change their color based on the distance remaining from the runway end to caution the pilot. The center line lights of a runway really help a lot in low visibility operations, and that is why they are there. So, you can see, for example, where the lights are white in color at every 50 feet. Now, when you have 3000 feet remaining, the lights become alternating red and white, red and white. But the last 1000 feet is only red, because you are cautioning the pilot that now you are entering an area where you will be probably reaching the end of the runway. So, white in the beginning, the moment you have 3000 feet remaining, it starts becoming red and white, and the last 1000 feet is only red colored. Runway touchdown lights, or TDZLs as they are called, they indicate the touchdown zone of a precision approach runway to the pilots. These are used mainly on precision approach runways. Why do we need these lights? Because we have to provide visual aiming point to pilots during night landings in precision approach, and as I mentioned, that will be very helpful in taking a decision. These are used, as I mentioned, in precision instrumented runways, because the aircraft must touch down in this area and not ahead of it. because if you land ahead of the touchdown zone, then you may not have enough landing distance available to stop the aircraft before reaching the end of the runway. Again, this helps a lot in low visibility operations. So, here is an example of touchdown light. You can see that they are marked separately. They have a separate color coding. The green lights at the beginning of the runway that you see are the runway threshold lights, and then you have these two bands of white lights which are indicating the touchdown zone lights. So, there are two rows of white light bars, one on each center line, and they start 100 feet beyond the landing threshold and extend 3000 feet of the runway or runway midpoint, whichever is less. Now, let us go to the taxiways. Taxiways, as you all are aware, when the aircraft lands and completes its landing, it has to exit the runway to allow other aircraft to operate. So, there are taxiways which allow the aircraft to go from runway to the terminal. Now, to illuminate the edges and center line of these taxiways, we use taxiway lights. Why do we need them? Because sometimes the taxiways can appear as large as runways. Many a times they are parallel to the main runways, and there have been many instances in real life when pilots have mistakenly landed on the taxiway instead of riding the runway. So, to avoid confusion in the night time between runway and taxiway, the taxiway end lights are blue and center lights are green. So, the edges of taxiways are always blue and the center lines are always green. Now, some taxiways, they also have lead on and lead off lights in the center line. These are to guide the pilot. Okay. So, these are alternating between green and yellow. So, the pilot is supposed to follow these lights, but when a taxiway approaches the runway, then they are yellow in color to give a caution to the pilot that you are now approaching a danger zone. So, here is a picture of the taxi lights. As you can see, all the lights at the edges are blue in color, and the ones in the center line are the green lights, which are not there at all airports, only at busy airports and also at airports which regularly experience bad weather. So, let us have a look in more detail. The green center line lights are very bright, okay, so that the pilots can see and follow them in the worst condition during day or night. Now, these lights, they are with a tough metal housing because aircraft may even go over them. So, they are mounted flush with the surface of the taxiway, as you can see in the picture. Only a very small portion which is required to illuminate protrudes above the ground, and actually the yellow line that you see is the center line, and these are painted slightly on the left or the right of the painted center line because the aircraft nose wheel might actually go on the center line. So, to avoid persistent loading, they are mounted little bit away off of the center line. Okay. Now, an interesting system is in operation at Changi Airport. It is called as the SafeGate taxiway system because it is given by a company called SafeGate. Now, what it does is, it actually illuminates the path that the aircraft has to take on the taxiway. So, the pilot need not remember which taxiway to exit and where to go. You can just it is guided automatically, and the slogan is, the pilot is supposed to just follow the greens. Okay. You can also notice that there is this red colored bar in the center. Okay. As you can see here, there is a red colored bar here. Now, this is also an interesting system. So, when there is a taxiway which can have two aircraft coming at the same time, then if you are giving permission to one aircraft to taxi, the other one is asked to hold before the red lights. So, these center line lights, they illuminate. This is all done automatically. The moment ATC gives permission for one aircraft to go on a particular route, all the other routes, they start getting these red colored lights. So, here is a summary of all the lights of the runway. You can see that the white colored lights are the edges of the runway. You have these two flashing lights which are the runway end identifier lights, REILs. Okay. Then you have the runway end lights, red in color, you have the threshold lights which are green in color, you have the center light of the runway which is also white in color, but when you are approaching a taxiway they become alternate green and yellow, and when you are near the end of the runway they become white and red alternatively, and finally when you come to the end they have become only red. Now we look at the visual approach slopes. Right. Why do we need them? These are slightly modern systems which provide a color based identification to the pilot, because they are now indicating to the pilot whether you are on the correct glide slope and also you are descending at the right angle. Okay. There are two most common approach aids available. One of them is called as the VASI or the visual approach slope indicator, and the other is called as a PAPI, which is the precision approach path indicator. Let us have a look at them one by one. The VASI system provides visual descent guidance to pilots during approach. It is a system of lights guiding the pilot to the desired glide path, and it works in relatively good weather conditions only. Okay. Now, this is visible about 3 to 5 miles in the day and 20 miles in the night, but only in good weather conditions. It consists of these bars. Okay. There is a near bar which is the downwind bar, runway near the runway threshold, and then there is a upwind bar which is the bar which is farther away from the runway threshold. So, it uses this 2-bar system, and each bar can have either 2 lights or 3 lights, but there will be 2 bars. So, let us have a look at a 2-bar VASI system. So, these bars are basically groups of lights which traverse to the end of the direction of the runway, referred to as a bar, and a bar consists of either 1 or 2 or 3 lights which are referred to as boxes. So, let us see how the 2-bar VASI system works. Now, if you are approaching and if both the bars show red color, it means you are actually below the glide path. If one is red and one is white, then it means you are on the correct glide path. And if both of them are white, that means you are above the glide path. Let me explain this by using a sketch. Let us say this is your runway and this is your desired approach path. Normally this path is around 3 degrees. So, if you are coming like this, then you will see both the bars will be white in color, and if you are coming like this, along this path if you are coming, then you will see both of them red. But if you are coming along the correct 3-degree path, then you will see the far bar will be red and the bottom bar or the near bar will be white in color. So, this is how you get to know whether you are on the correct glide slope or not. Very, very helpful for landing safely during bad weather conditions. Here is an example of a 2-bar VASI system, just one red bar and one white bar, and currently you are at the right inclination. Or you can have a 4-light 2-bar system. So, here there are 2 lights in each bar. Okay. So, similarly one can have 3 lights also. Here is the working of 3-bar VASI. Now, in 3-bar VASI you have to be very careful because you have to look at the light. Now, there are some mnemonics available to remember. So, if all the 3 bars are red, that means if you have red over red, it means you are dead, that means you are coming at a very low, you are below both the glide paths. In this case, there are 2 glide paths which are permitted for you to come. In this, with the 3 sets of light red, you are below both the points. On the other end, if you have top 2 bars as red and the bottom one as white, you are on the lower glide path. So, red over white, you are all right, this is permitted. Similarly, you may be at the upper glide path. Again, you are having red over white, you are right, no problem, you are on the upper glide path. But if you have all 3 white over white, you are very high as a kite. That means your approach angle is more than the glide path. So what you need to do is, you need to ensure that either you are this or you are this. Okay? You should not be this, and you should not also be this. Here is an example of a 3-bar VASI system. This indicates you have red over white. You are right, no problem. This is you are at a lower path. Then the next system is the PAPI, or the Precision Approach Path Indicator. The PAPI system is more precise compared to VASI. It gives more precise indications to the pilot of the approach path of the aircraft, and it also has lower operating and maintenance cost. You have only 1 bar instead of 2 bars that you have in VASI. You have only 1 long bar, and the lights are laterally. It eliminates the need for the pilot to look at 2 bars, the far bar and the near bar. Okay? Just like in VASI, here you can look only at 1 bar. So how does it work? You have a series of lights, generally 4 lights on the either side of the approach. Okay? So if now all 4 are white, you are too high. If you have 1 red and 3 white, you are slightly high. If you have 2 red and 2 white, you are on the correct path. If you have 3 red and 1, you are slightly low. And if you have all 4, you are very, very low. So this is how the PAPI system works. Okay? Now finally we look at runway and taxiway signage, right? So the signs on the runway, they indicate the distance of runway remaining in thousands of feet. Okay? So we have an example where on the right hand side of the runway or on the left hand side of the runway, you will find these numbers written. So if you see number 3 written on runway 22, it means you have only 3000 feet remaining. So apart from the lights, you also have these numbers on the runway to tell you how much is remaining. Then you have runway exit signs. It tells you while you are on the runway, if you see a sign like this, it indicates that there is a taxiway B on the left and you are going to exit that. So you can see they are located just prior to the intersection on the same side of the runway as the exit. So if you are exiting on the left, you will see B with left arrow on the left hand side. So the pilot knows that now very soon I am going to come at a runway B, which is towards my left hand side. On taxiway, you have signs which are with black background with white with a yellow character, such as shown there A3. It identifies on what taxiway the aircraft is on. So if you are on taxiway A3, you will find black color background and yellow color A3 written on that. Okay. If you see a yellow background with black color on the other hand, this identifies a crossing taxiway. That means you are going to cross a taxiway now. Okay. And if you see a red sign like red background 31R, it indicates that you are going to now come across a runway, and in this case it will be runway 31R. So the red color reminds the pilots not to proceed further without permission from the air traffic controller. So this sign indicates that you are on taxiway A, and very soon you are going to go for a hard right turn to go to taxiway A4. This indicates that you are on taxiway A3 and you are going to cross now a runway 31R, 13L. That means you are going to be on the middle of the runway 31R and 13L. It may not be the middle, it will be somewhere in the center, not the end. Okay, then we have runway approach area hold position sign. Now taxiing past this sign may interfere with operation on the runway. So like this red color with white means you are going to now approach, you are going to go to the approach end of runway 15. Okay. So as you can see, it is located next to the yellow holding position mark where you have to hold on the pavement, and it tells you that now you are going to reach the approach zone of the runway 15. That means you have to be careful, look for aircraft which are approaching. And we also have taxiway direction signs. These are yellow signs normally seen on the next to the taxiway location sign, and they indicate the direction of intersecting runways. So this sign shows you that you are on runway A, you will be going to taxiway A on the right hand side, but you will be crossing taxiway C on both sides. So you can see now you are on this particular taxiway and you are going to go like that. So, taxiway Charlie is on the left and right and alpha takes a turn to the right ahead. That is the indication that the pilot will get. You also have flashing amber taxiway lights. These are the warning lights for the pilots that they are about to taxi into a runway, and they consist of these dual flashing units. Okay. One mounted on each side of the taxiway. So, on both sides of the taxiway you will find these lights and you have to stop there and proceed further. Right. So, taxiing past these lights, it requires clearance from the ATC. Without that you are not supposed to go. So, you can see, for example, here this is a runway, this is a taxiway which is U, and from this taxiway U you are going to come to the end of runway 7L. You are going to come to the end of the runway 7L, right, and you have these yellow lines lighted and you also have these two flashing lights at the end. Now, right now it is okay, you can ask for permission, but if they are like this, then it means you should not proceed further because the runway 7L is now active. Some operation is going to take place, so do not go there. Okay. So, unlike the yellow guard lights which means caution, the red one means definitely you must stop. So, here are examples. Now, the purpose of these is to reduce the risk of deadly runway collisions. They are placed along the whole short line, they are switched on by ATC and they must be extinguished before the aircraft can proceed further. Finally, here is an example of how the stop bar lights work. Now, in the figure on the left the lights are on, so therefore the aircraft is not supposed to go. In the right hand side the lights are off or they may be yellow in color and there is a green colored direction, that means the aircraft can enter the runway. So, with that we come to the end of this session. I hope this particular lecture will now help you to identify these symbols, these markings, and when you next take a flight and land or take off from the airport, you should be able to identify these lights and appreciate their safety. Thank you for your attention.